Alright, this video is about solving equations. And in algebra, we often get to a situation where we've got an equation that has an unknown value that we usually call a variable. And it's represented by a letter. Usually it's x, sometimes it's the letter n or a. And all that means is a number that we're not sure the value of, or that we have to solve for the value of. And after we solve an equation, we've done these steps, and we get an actual answer. Say we have something like x equals 5, and we have that as our solution. At the end, we can go backwards and use that solution and plug it back into our equation and see if it makes sense. And so we'll go through some examples of that. So to solve equations, we actually want to use what are called inverse operations to cancel out whatever's going on around our variable, our unknown value. And after we've done that, then whatever we do to one side of the equation, we have to make sure to do to both sides of the equation to balance it out around the equal sign. And then we will have our value, and then we can kind of plug it back in and check our work. So our inverse operations, if you're working with addition, the inverse is going to be subtraction. In other words, these two are opposites. So if your equation involves subtraction, then the inverse is going to be addition. Same thing with multiplication and division. They're opposites. They cancel each other out. And remember that, and I've mentioned it before, but a fraction is another way of representing a division problem. So when we see a fraction bar, we could think of that as being a division bar, or divided by. And I threw on this list as well, which we'll see a little bit later on, is squares and square roots. When you have a number squared, or a number raised to the second power, you can cancel that out, do the opposite by taking a square root. So here's three different equations, and I'm hoping that you can see that they're three different ones. I'll do them in different colors. I just wanted to put them all on one page to kind of save room. So we have x plus 5 equals 14. So we want to solve this one for x. The equal sign is going to be our sort of our dividing line here. We have x plus 5, so the plus 5 gets canceled out by doing minus 5. And then whatever we do to one side of the equation, we have to do to the other side. So on the right side now we have 14 minus 5. That's going to give us 9. And on the left side of the equation, we're simply left with x, because the plus 5 and the minus 5 canceled each other out. So we've got a final answer of x equals 9 as our solution. And then we can go back and we can check that answer, check our work. If we replace the x in our original problem, x plus 5 equals 14, with the number 9, then it should make sense, and it should work. So if we have 9 instead of x, we say 9 plus 5 equals 14. And we'll just kind of ask ourselves, is that true? Does that make sense? That was our original equation, but we're plugging in a 9 to see if we were correct. And that's right, it does make sense. We have 9 plus 5 equals 14, so we're good. Here we want to solve for n. We have 3n equals 21. Or again, if we don't see a sign in between the 3 and the n, we're going to assume that we're just multiplying. Whenever you don't see an operation, we're going to be representing multiplication. So 3 times n equals 21. To cancel that, we divide by 3 on both sides of the equal sign. So again, here on the left we have n by itself, and on the right we have 21 divided by 3, which is 7. Okay, the last equation here, we've got a over 5 equals 2, or really a divided by 5 equals 2. So to get rid of the divided by 5, we multiply by 5 on the left and the right. That leaves us with a equals, we have 5 times 2, which is 10. So those are what we call one-step equations, because there's only one operation happening besides our variable, besides our unknown. So again, we do the opposite of that operation. We do it to both sides, we get an answer, and then we can go back and we can check our work on all of these and see that if we use that number, if we plug that number back in, that it does make sense. On this one is saying 3 times n is 21. Well, 3 times what is 21? 3 times 7 is 21. So it does make sense. When we have more than one thing happening in our equation, usually it's both multiplication and division happening. I'm sorry, usually it's both addition and subtraction and multiplication and division happening. We want to make sure we cancel things out in the right order. So I made a list here for 2 steps. It's usually the case that we want to get rid of addition, subtraction first, and then get rid of multiplication and division. However, if we've got parentheses in our problem, that's gonna change the order there. So what I wanted to point out here was when we normally just do math forwards, we usually use order of operations. We call it PEMDAS, right? We'll do parentheses, and then we'll do exponents, then multiplication, division, and then addition, subtraction. But when we're solving an equation, we're doing everything backwards. So that's why when we're solving equations, we actually want to get rid of the addition and subtraction part first, since that's kind of the furthest away from our variable. And then we can kind of work backwards from there. We can get rid of multiplication and division. We can get rid of if we have exponents or if we have square roots that we have to take care of. And then finally, if we have a parentheses right next to our variable, we can get rid of that last. So here we got negative 2x plus 4 equals 18. We want our x by itself. We have multiplied by negative 2, and we also have 4 being added. So let's get rid of the addition and subtraction part first. Again, because it's sort of the furthest thing away from the x here. So that is going to cancel here on the left. We're going to be left with negative 2x equals, on the right side we have 18 minus 4. So that is 14. And then you've got a new equation now. We have negative 2x equals 14. So to do the opposite, to cancel that out, we want to, it's being multiplied by negative 2, so we want to divide by negative 2. We have to do it on both sides, the left and the right. And finally, we're left with 14, or positive 14 divided by negative 2, which is going to give us a negative 7. All right, the middle problem here, we have 13 plus 3x equals 22. We want to get the x by itself. Okay, that's what we're going to solve for. So we want to get rid of the addition and subtraction part first. We have a positive 13 that's being added right here. So we're going to do the opposite, subtract 13 from both sides. That leaves us with 3x on the left, since, again, this cancels out. And on the right, we have 22 minus 13, which is going to leave us with 9. Yeah. Now we've got 3x equals 9. Divide by 3 on left and right. And we've got 9 divided by 3, which gives us 3. So again, 2 steps. First step is we get rid of the addition and subtraction. Then we have a new equation we're going to solve. In that step, we're going to get rid of multiplication and division. And at the very end, just make sure our variable's by itself and make sure that our answer makes sense. Let's do the last one here. Let's do that in green. We have 1/5 x plus 6 equals 9. Again, the 1/5 x, in fact, you can think about that in 2 ways. You can say that's the fraction 1/5 multiplied by x, so it's multiplication. Or you can think of it as it's x divided by 5. Again, that's 2 different ways of saying the same thing. Either way, you want to get rid of this plus 6 first. So you want to cancel it out by doing minus 6 on both sides. It cancels this out here, so we're left with 1/5 x. And then on the right you have 9 minus 6, which gives you 3, positive 3. So now we want to cancel out the last part is 1/5 times x, or x divided by 5 is really another way to think of that. So we want to, instead of divide, we want to multiply. We're going to multiply by 5. Multiply by 5 on both sides here. All right, that's kind of in the margin there. This cancels. We get our variable by itself, and on the right side we have our solution, which is 5 times 3, or 15. Let's continue this in the next video.